today is derivatives and anti-derivatives of Taylor polynomials and Hawa series. Okay? So basically, like you say, let this guy right here be a function of x. Okay? So if this is a function of x, if I want to take the derivative, I'm taking it with respect to x. So all of this other stuff, all of this in stuff here is going to be like a coefficient. And what do coefficients get to do? Woo! Go along for the ride. Okay?
Once on a roller coaster.
Yes, once on a roller coaster. Okay. So they get to go along for the ride. So basically, that coefficient, when taking the derivative, would go along for the ride. Then I use my power rule. The n comes down in front, and I subtract 1. Yes? Now, a lot of times, once you have this, you can simplify. Okay? Not always, but a lot of times. Because what happens when I go plug 0 into all my n's here? What's the first term become? 0. So it's not even there. So if I jump and start at 1, is that going to give me the same thing? Emily, why no? In this particular case, you see, like if I plug in 0, I'm going to have, so let's write out the first few terms. So plug in 0, what do you get out? 0 times some blob, which is 0, plus, plug in 1 next, 1 times a sub 1 times x minus c to the 0, okay, plus 2 times a sub 2 times x minus c to the first, plus dot dot dot. So that 0 part here, we could start at 1 and we've got the equivalent thing. So in most cases, we can't change where we're starting and say they're equal. But in this particular case, we could because that was a 0 term. Makes sense now? Okay, so if you can reduce it, reduce it. That's not always the case, though. Okay, so let's just look at this one. Find the derivative of this. And then we'll get to some more fun ones. So we kind of start here. A sub n does what? Goes along for the ride. So that's like my coefficient. And then I take the derivative of x to the n. So that becomes n x to the n minus 1. So what happens as I go and plug 0 in? The first term is 0. So can that guy actually simplify to start at 1? And everything else is the same. What about at 1? Does that simplify to start at 2? Or is that an actual term? Yeah, it's a non-zero term here. It's an actual thing that's existing that I can see. I cannot go any farther. And sometimes you can jump ahead a couple. Okay? Okay, the antiderivative, again, is just like the power rule. That coefficient went along for the ride. I do my power rule by adding 1 and then dividing by my new power. And then I still have, though, a plus c. Okay, when doing these guys, the radius of convergence is going to be the same. So that radius is going to be the same for the original, the derivative, and the antiderivatives. But the endpoints may differ. So remember how we had those question marks? Those endpoints could be different. So that's just a little side note. Okay. Okay. Huh? sub n here? What's the a sub n part? What's the coefficient part? Is this part a coefficient? Do you have any x's in there? So it's part of my coefficient. Is this part a coefficient? So all of that, oops, is a coefficient. Is this part now a coefficient? No, because I've got the x's involved. That guy went along for the ride. And now I'm going to do my power rule. And what happens at 0? I get out. When I plug n to be 0, I get out 0. So can I actually simplify this? Yes. There we go. Yes, please. Because I would ask a multiple choice question, and this one may not be on there, and this one is. So I want you to get in the habit of knowing how. Oh, it is. Thank you, Cameron. Good job, Cameron. Captain Cam to the rescue. Did that first block too. I don't know why. Okay. My brain has a little hole in it today. Okay. So everybody good there? Okay, let's do B. What's the integral of f of x dx? Start out with where it started. Coefficient. Went along for the ride. And now I got to do my power rule for the antiderivative. So we have that. What? I don't know what is wrong with me today. It's a 5. Gosh, I'm at like 8 out of 10 now. No! Stop. Ah, you guys are harsh on me today. I have a lot going on. My mind is very full. Stop it. Chris, don't touch that. All right. Good now? Oh, hold on. What did we forget? I'm not forgetting. I'm putting it here.
No, you scrolled.
Well, no, you guys are distracting me. Okay, plus C. Okay, so the question was, do you not have to simplify? We'll plug in 0, Cody, and that's that's going to be, what? 1 times 1, x minus 5 squared, negative 1. So I don't have a 0 term. So I can't jump forward. I need that term. The only reason I could jump forward was because before my first term here was 0. And so it was just like, I don't care about it if it's 0. Does that make sense? Yeah, that makes sense. Okay. All right. There is something tough about this. And half of you on a quiz or test are going to try to do this. going to try to do that. And that is wrong. Okay? So what I recommend is you think, I want to get, just like in before, you want to get that x minus c part with the n. And get everything else for your a sub n. Okay? So you want to separate out that x minus c to the n part. So in this case, what's my c value? Am I subtracting anything? So it's 0. I'm centered at 0. So I need to get that part by itself and everything else. So just to rewrite f of x, that's like x to the n over 4 to the n. Or you could have said 1/4 to the n if you like to see it out in front. Okay? But now I've got this part separated, and then this part, this 1 over, is my coefficient going along for the ride. Okay? Okay, so go find f prime, go find the integral. Huh? What's it? Okay. All good? So do we understand the basics of how to take the derivative and how to take the antiderivative?
Yeah.
Yeah? So now you're ready to see it in some AP kind of lingo. Okay. So first off, I need you guys to correct your notes here. So go scratch out your line and correct it. Don't even. Okay. So go scratch your line out here and make this. And then we'll talk about it. Is it different? Scratch it. Oh, it didn't say. Okay. Scratch this out. We'll write it together, okay? I saved it. So when I want to take the derivative of a number is going to go to what? 0. For that first term. We're just going to go term by term. The derivative of this guy is going to go to what? Well, that's 1, but I have a number in front of it, which is just f prime of c, whatever that value was. That's a c. Plus, what happens here? This 2 goes down in front. I have my second derivative of c over 2 factorial times x minus c to the first now. Plus, dot, 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 plus, so I'm running out of room. This guy's going to be, what's the nth here? N times the nth derivative of c divided by n factorial times x minus c to the n minus 1. So what this is saying basically is sometimes it's easier to go term by term to see what's happening. And sometimes it's easier if you just want to do the whole thing. Okay, like that whole series. What we just were doing. So I'm going to show you an example of when it's easier to do both cases. So here's an AP example, and they gave me this Taylor series centered at 1, and they told me something great. It says find the first three non-zero terms and the general term for f prime. Well, do I have these terms already written out? Like, do I see all the terms? Okay, I don't see all the terms. So look down here. This is going to be a different one, and it's going to want the first three non-zero terms, and maybe the, okay, general term, I'm not sure. But, do I see these guys written out? Okay, when I see them written out, it's going to be easier to do that term by term that we just did. If I'm given that whole big blob, it's going to be easier to just take the derivative of that whole series. So here, let's first state what f prime would be. Cameron, you got this? Can you find f prime for me? What happened to those two points? Yeah, they canceled out. Right? When I brought my power down of n, it canceled with that denominator n. So there's my derivative. And it wants me to write the first three non-zero terms. Okay, so let's do that.
Go.
So plug in 1 first, and then you got out 2. Okay. Plug in 2 now. So negative.
4.
So negative 2, 4, 2.
Okay.
So negative 4 times what? X minus 1 to the first. Now we're plugging in 3. So that one's a positive. 8 times x minus 1 to the second. How many did it want? First 3 non-zero terms. So here are my first 3 non-zero terms. Okay? Then it wants the general term. So I'm going to say plus dot 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 plus in order to get to the general term. This guy right here is just your general term. You've already gotten it. So you don't have to try to find the pattern again. You already got the pattern. So that's going to be that negative 1 to the n plus 1 times 2 to the n times x minus 1 to the n minus 1 plus dot dot dot. So again, here's my general term. What do you think? Doable? Okay, we got to get through this next one. We're going to do part C. Part D is kind of like a bonus if I remember. So we're going to do part C. So here I see I have the terms written out. So this one's actually kind of very extensive. So let's not like get overwhelmed. First it says, write the first four non-zero terms of the Maclaurin. So automatically I know I'm thinking C is 0. Do I see that C is 0? Okay, that corresponded. Okay, so just my little thought. Okay, so then let's go back. Write the first four non-zero terms for f prime of t squared. If I asked you to find f prime of 2, what do you first have to do? Find f prime. Then you can go plug it in. So same thing. My first step is to find f prime. So let's set f prime. And this is going to be easier to do term by term. Okay, agree with that? It's canceled. I wrote down 3n. Okay, so that was my first thing. My second thing now is I get to plug in the t squared. So now we're going to find f prime of t squared. So everywhere you see an x, you're going to plug in t squared. So that would be t to the 6n minus, oops, 6n minus 2. Everybody get there? Right, you haven't really got it. Then it says, if g now is the, oh my goodness, what do they have me do next? Take the integral. So now we have to take the antiderivative of this guy. So the antiderivative of this guy. Yeah, it doesn't go back to the same thing, does it? We're probably doing more than we definitely have to. It's just wanting the first few terms, but this is good practice. Oh, how did I do this? Okay, 3t to the, what did that become? If I add 1 to it, it's going to become, we're adding just 1, 6n minus 1. Because you're just saying plus 1. So then divided by that power, which is 6n minus 1. And this is, I mean, we didn't have to do that for this problem, but it's practice, like I said. And then it says, use the first two non-zero terms to approximate g of 1. So then my last step, we'll do it in purple, g of 1 is going to be approximately what? x minus 3/11. If you really want to simplify, power to you. But you do not have to. Cool? Okay, did I ever have to do this right here with the whole plus 1 minus? No. It was just asking me for the first 4 terms. But I wanted to practice that for you, okay? So on the test, don't do that if it doesn't ask you for the general term. So if it never says find the general term, don't worry about that. Okay, it will just take more time. Right here. It said use the first 2 terms. They said this is now G. Okay. Now, we have in our notes other AP examples, and I think I put in there actually a ton. Radius of convergence, some other things. I would like to do these. We may have to end up doing them on review days. So remind me, there's some really, really good ones in here, okay? There are some AP problems. I know we're out of time today, but on some review days, I think that review days. Okay.
Jeez.
So,
That is significantly more than you usually give us. Thank you.